Bravo X-ray. My location is Northern Ontario, and this is for the Intercontinental Amateur Traffic Network. The net controller in about 8 minutes or 7 minutes or so is the Maritime Mobile Service Network for the Gentleman Bob M5IOY from El Paso, Texas, and he'll be the controller at 12 noon. But in the meantime, folks, this is Mike, Victor Echo 3 Romeo Bravo X-ray. My location is Northern Ontario. Would anyone like to check in? Please go ahead. I heard Alpha and then Oscar and the no traffic there, but I did copy her in Florida, but I'm you'll be able to, you might want to listen to yourself on one of the FDRs, the web FDRs or something. And
this is the Rockwell Collins Avionics HF radio called 718U-5M. The M stands for the fact that this is the microprocessor controlled control box, and the radio covers 2 to 30 megahertz in 100 hertz steps. 100 hertz. This is the finest resolution, but it also has 10 memories or 9, I'm not quite sure, that can be programmed. This is memory 1. Memory 2, memory 3, and so on. And this is the manual position. The modes that this radio can cover, the modulation modes, is upper sideband, lower sideband, amplitude modulation, CW, although with the single sideband filter it doesn't have a narrow filter for that. SVU and SVL are secure voice modes, upper sideband and lower sideband, but for that an additional encryptor is needed. And this is an RF test position. So it's basically very useful for ham use. Does that quite well. Output power is 100 watts on all frequencies from a solid state amplifier, and the unit exists of a 671U-4A receiver exciter in its frame. The frame is a 990C 3D tray. And here we have the amplifier. The amplifier is the 548S3, and the mounting for that is the 990C2. The receiver exciter controls the amplifier through this cable here. This is the RF input that goes to the receiver exciter. It's being amplified. Then it's being fed into a automatic antenna tuner that's part of this unit, and another cable goes to the control box, and then we of course have our microphone connection. We have a 600 ohm output. For that I'm using this speaker here, and we also have the option to use a 600 ohm input. Right now that is not used. I have the microphone on the what's called a carbon microphone input, a biased microphone, and that works quite well, as I'll show you in a minute. This unit is still in use in the aircraft world. In the military it was used as the ARC-174. And like I said, as in the civil aviation world, it was known as the 718U-5M transceiver, still used in many aircraft today. It stems from the early 70s, but it was produced all the way till the late 80s, so almost 20 years of production. Initially, this was developed first, the 671U4, that was then used with tube amplifiers, which is obviously not what this is here. So this was developed later as a more compact version of the old tube amplifiers that went with the early versions of this unit. This is a very late version, as the Rockwell Collins. They were also produced under the Collins name, but when Collins was acquired at the end of the 70s by Rockwell, they were still produced under the Rockwell Collins name, and I think this one is from '86. So it's a late model. And like I said, the control boxes, this is an upgraded version of that. Standard 718Us had a manual controlled unit without memories. This was mostly used by the military, this particular version of the box, so for the ARC-174, and that's the reason why there is the secure voice modes on there, so that the military could not be eavesdropped upon. It is an incredibly professionally built piece of equipment. I'll show you the insides later. I'm not going to show you the inside of these particular two because like you can see here, it still has the seals and there is a seal in the back. But I have another one of the receiver exciters, a Collins version, a slightly older one, which I'll show you in a minute, that you got an idea what it looks from the inside. It's extremely professionally built. Let's see what I can do. Well, in order to test the transmitter, we will switch to this dummy load here, not to bother anyone. Okay, we're on the dummy load now. What I can do is switch the unit to AM. In AM it gives a 100 watt carrier, which then modulates down as you modulate more loudly. So that's a different kind of scheme than standard AM. It is a single sideband with carrier reinserted, and it sounds like normal AM. The receiver has a true AM 6 kHz filter, so that's good. I'll show you what happens when we start to transmit here. Alright, that is the tune cycle. That only happens once. Once you're on the channel, it stays tuned. However, when you change the frequency, oops, I'm still on memory. When you change the frequency, then it will retune. But like I said, it does that only once. So we're on AM now, and that will show you the carrier. It is a 100 watt carrier. Well, when I modulate, it goes down. As you can see, it's a down modulating concept to the point where it never can over modulate. It works actually quite well. I'll let you listen to it in a minute. So if I go to a different frequency, like I told you, it goes all the way from 2. We're at 2 megahertz now, and it tunes there as well. It's still 100 watts there, and the highest frequency is 29,999. And it does 100 watts there too. AGC works really nice. So it covers all the ham bands. That's kind of nice. And everything else in between. Now, as you can see, I tune it into 50 ohms. The tuner, the automatic tuner that's in here, can handle everything from coat hangers to long wires. Actually, this particular one, the tray, has an optional extension coil that can either be used or bridged depending on the type of antenna used. So in cases where you have a very short antenna, the proverbial coat hanger that I was talking about, this unit will still be able to get that tuned. Inside here is a large series coil that is normally shunted when not used, but when the tuner can't find a solution, it will give a signal to open that coaxial relay, to open the shunt, and then you can tune very short antennas. That's an option. Not all 718Us have that. This particular one does have that. Let's see how the modulation sounds. Alright, we're still on 325, 14.325. I got my Jesus tuned to the same frequency. And let's see how that works. Got a little bit of feedback here.
1, 2, 3.
That's a bit loud.
1, 2, 3, over.
That is the upper sideband.
1, 2, 3, over. Testing.
That is the upper sideband. Switch the unit to lower sideband. Do the same here.
1, 2, 3, over. Testing. Lower
sideband. Let's see how it works in reverse. Oh, 1, 2, 3, 4, 5. As you can see, it is exact on frequency. The two radios agree with each other perfectly. I do have the TCXO in the Yaesu, and of course the Rockwell Collins has that standard, so the radio is very accurate in frequency.
1, 2, 3.
Let's try amplitude modulation. There we are, AM.
1, 2, 3, 4, 5. 1, 2, 3, 4, 5. As you see, that actually sounds quite nice. It is, like I said, it is only one sideband that's being transmitted, but it is what's called AM equivalent, and it sounds very good. 1, 2, 3, 4, 5.
The Yaesu sounds less good.
1, 2, 3, 4, 5.
But ham radios are never very good with AM. But I can tune into a broadcast station later if you want. So it works quite well. Alright, I promised you to tune into a broadcast station to listen to the AM mode. Let's do that. This is the 12 megahertz band. We got a broadcaster there. There's not too much broadcast anymore on shortwave, but the religious stations are always a reliable bet. You see, it sounds quite well. AM, of course, we can also listen to it in sideband. But on AM, you truly have a 6 kilohertz bandwidth. Let's have a look at the individual modules for this radio. Take them out of the trace. Here you see the back of the amplifier / tuner. This is the assembly that contains the additional series coil that I was telling you about. I am tuning this, as I told you earlier, into 50 ohms. It does that quite well. But like I said, you can connect any long wire on there, or if you use a balun, you can use dipole antennas. This thing will literally tune anything you can throw at it. There is 2 variable capacitors in there, 2 Jennings, and 1 variable inductor in a T network, and obviously that's automatically tuned. Like I said, I have seen pictures of the inside from the manual that somebody once showed me, but I don't want to open this unit. It still has the seal, and this gives you a pretty good idea though. Let's have a look at the well, before we do that, when we look at the control box. This is the control box. Like I said, the military use this particular control box. Here you can see it. It's the C11289/ARC-174, the control box that was used by the military for this radio. So this particular one probably had a military usage in its life at one point, which is probably the reason why it's in such good condition. But like I said, in the civilian airplanes they use a simplified control box without a microprocessor. Here is the interconnect cable. This goes to the receiver exciter, this goes to the control box, and this goes to the power amplifier / coupler, and this is the coaxial cable for that. I forgot to tell you the unit runs off 28 volts. That is kind of standard for aircraft. 24 will work as well, but 28 is the nominal voltage. It draws about 12-13 amps on average under those conditions. The peak at two-tone modulation is about 22 amps, if I'm not mistaken. Let's have a look at the receiver exciter. The receiver exciter module out of its tray. This is the mating connector. The receiver exciter has a separate output for transmitter and receiver. That's why there is a combiner coaxial relay in here. This is the output that goes to the control box and the PA. This is an additional output for a voice encryptor that I told you earlier. I don't have that, but if you want, you can hook it up there. That's where your secure voice unit would connect to the KY, whatever. That's usually the designation they use for those machines. But as you saw, it runs perfectly without it. That is the mounting, Rockwell Collins, and it is not very heavy, obviously. It's just aluminum. And then we have the receiver exciter, which is obviously that connector that you saw earlier, and this mates with it. And here we see what we actually are dealing with. This is not good light. Let's do that again. That's better. Why doesn't it focus? There we go. Rockwell Collins, Rockwell International receiver exciter 671U-4A with part numbers and everything. Like I said, there is still a seal on there, so the one that I showed you on the inside is a different one that I have, a Collins version, slightly older. The difference mostly between the Collins version and the Rockwell Collins is the Collins has flat pack integrated circuits, and those are very hard to obtain nowadays. So Rockwell redesigned this whole thing for use with more modern integrated circuits, the 14-pin dual in lines like the 5400 series. So if you ever have to replace an integrated circuit in this unit, you're better off, because they can still be found easily, those TTL kind of series and CMOS. But the Collins version has the flat pack version of those chips. They perform exactly the same function, but they're just incredibly hard to find. So with this unit you won't have the problem. Not that it's a big deal. The unit is extremely reliable. I mean, developed in the end of the 60s, used all the way till the end of the 80s, and the reason for that was because the incredible reliability. And as you will see, the way it's built is just unbelievable. Let's have a look at that. Let's have a look at the inside of the receiver exciter of the 671U-4A from Collins. Avionics transceiver. As you can see, it is a quartz cage concept. This is the RF module. Also includes the driver stage for the PA. Here are several cars. I'll show you that in a minute. This is the power supply that takes 28 volts in and generates all these internal voltages. It's basically a switch regulator. Okay, here you see the inside. The section you have here is the synthesizer. Now, at the time that this was developed at the end of the 60s, beginning to I guess it was the end of the 60s, this was a revolutionary design, a synthesizer that could cover 2 to 30 megahertz in 100 hertz steps, everything derived from a single master oscillator. That was unheard of. This was state of the art. And as you can see, it occupies almost half of the card cage, but it does the job. Here we have the serial control receiver that basically interfaces with the control unit that I showed you earlier. It's a serial protocol, modulo 2 protocol it's called. There are different kind of interfaces available depending on the length of the communication cable that is needed, and this was the one that was most used for aircraft installations. This is the IF receiver. This is the transmitter IF. As you can see, there is 3 Collins mechanical filters, 450 kilohertz center frequency. Here we have the AF amplifier, audio amplifier, and modulation stages. Here are the interfaces to the outside world connector, which is basically a board with a lot of filter chokes, but there is also a latch interface for the a band selector for the PA, which is also obviously selected automatically. As you can see, this is built very well. It is a concept that is identical to the 651S1 receiver. Actually, that receiver is almost similar in concept as what you see here. The only thing is this is a transceiver. The other one was a receiver. The synthesizer that you see here is the same as that receiver, and also the IF card is the same, and the RF unit, as well as the power supply unit. So this is basically a transceiver version of the 651S1 Collins receiver, very well known concept, very well known receiver. People that have that receiver or have ever seen it from the inside will immediately recognize this. It's very similar in concept, in design as well. Let's take out a single card. I'll show you what that looks like. Alright, I took 2 cards out. The amplifier IF and the synthesizer divider. Oops. Synthesizer divider. As you can see, they used flat pack ICs in those days. It's a kind of an early style SMT approach. And here you see the IF card. What I like about this is what they called made during the golden years of radio construction. And what do we mean with that? Well, every semiconductor is in a metal case, not plastic, and every semiconductor is in either a metal case or a ceramic case. The capacitors are dry electrolytes in a steel case with a glass insulation, and the wiring is all Teflon. This is a Teflon coaxial cable that terminates into high quality coaxial connectors. The connector here is not an edge connector, but it is a standalone connector that mates with pins. I don't know if you can see it, a pin style connector on the motherboard. The PCB material is of high quality. It is a multi-layer. What's in those days was really a state-of-the-art technique. Nowadays that's common, but in those days it was not. The F-style mechanical filters are in a steel case. That's actually the difference. I told you earlier, this concept is identical to the 651S1 receiver from Collins. However, that receiver is not as professionally built up. They use plastic style F-style mechanical filters, and these are hermetically sealed and have much better aging characteristics. So as you can see, it is absolutely superb. These were definitely the golden years of radio construction. Some people look at paintings and appreciate it. I look at this and I see art. It doesn't get better than this. If you look at military radios of today's age, it's nothing like this. This must have cost an absolute fortune in the days. Keep in mind, this was designed at the end of the 60s, as I told you earlier. The whole unit is solid state. In the end of the 60s, hams used like a KWM2A, which is completely tubes. This particular one has semiconductors with date codes of 1974. So that was around the time that this was built. Probably not visible on the video, but this is a Collins version. The receiver exciter that you see here was made all the way up to the mid-80s, mid to end 80s I think. I have a late version from Rockwell Collins that has date codes of 86, so it must have still been produced then. This is, like I said, a Collins version, and it was made before Collins was acquired by Rockwell, which happened I think in 68 or 78 if I'm not mistaken. One thing I didn't want to keep from you, this is a diagram for the RF unit. Remember I told you about that, it's in here. Here you see the first mixer of the receiver. And there is a similar mixer for the transmitter. There the signal goes that way, here it goes for the receiver that way. But what I thought was funny is that this is basically done with 6 JFETs, a balanced mixer, 3 in each branch of the mixer. And keep in mind, this was designed at the end of the 60s. That is exactly the same concept that you see in today's high-end ham radios. A whole bunch of JFETs in parallel. And this was already done by Collins before the 70s even started. Now you probably understand why we were able to send a manned moon mission in 1969, because technology was much farther ahead, also radio electronics, than what people realize. And this radio was actually designed in that period. That alone makes it a very interesting historic piece. Lower sideband in the 40-meter band. Not much going on there during the day. I got quite a lot of noise here. On 40 meters I have consistently 7 S indicators of noise, so 7 S points. In any case, that's it. The 718U-5M Avionics HF transceiver from Rockwell Collins. A very professional piece of equipment. Thank you for watching this video.